Hi folks, welcome to the 3.4 video. In this video, we're going to talk about contingency tables. And so we're going to use two examples to talk about them, okay? But basically, contingency tables give us a way to look at probability for like a bunch of different things without having to give like P of this equals that, P of that equals that. We get to actually figure that out from the table, okay? And so let's take a look at this table. This table shows the number of athletes who stretched before exercising and how many had injuries within the past year, okay? Now, I don't know about you folks, but I am terrible about stretching before I exercise. So this example kind of hit home a little bit. But we get to use this as a chance to also think about how do we turn sort of words into symbols and then think about them mathematically, okay? So part A says, what is the probability that an athlete stretches before exercising, okay? And so I'm just gonna say that that's P of S. I'm gonna say that stretching is the S. And if I look at this, I notice that there's a row here that says the number of people who stretched, okay? Now, some of them had injuries, some of them did not, but in total, we had 350 people who stretched, okay? So what that means is I have 350 folks who stretched. Out of how many people did we look at altogether, okay? And it's not like the does not stretch category, but it's like how many people altogether? Well, since there were 800 people, right, that is sort of our total. So we have 350 divided by 800. And if we type that into the calculator, we get a probability of 0.4375, okay? So in other words, we have about a 43% probability that the athlete stretches before exercising, okay? All right, now part B says, what is the probability of athletes stretching before exercises given no injuries in the last year, okay? And so now we're actually being really specific. We are actually only curious about the category of folks who did not have injury in the last year. That means that our probability, okay, so probability of stretching given no injury means that I need to look at the number of people who stretched, so 295, out of how many people had no injuries, 514. So my probability that an athlete stretches before exercising, given that they had no injuries, is going to be 295 out of 514. I type that into the calculator and I get 0.5739, okay? And so what we can see here is that an athlete who had no injuries, there was a 57% chance that these people stretched before exercising. So for the folks like me who didn't stretch, it might seem that we're a little bit more prone to injuries than the folks who do stretch, okay? So not telling you what to do in your workouts, but maybe you give the stretching a try, all right? But let's take a look at a second example, okay? And so in our second example, we're looking at some cyclists, so people who are bicycling, and what kind of routes they prefer. So we're going to let O talk about the older folks and H talk about a hilly path, okay? And so there's lots of things that we could look at. So we've got younger folks and older folks. But then there's sort of three different types of paths that they prefer: the lake path, the hilly path, or the wooded path. All right. Now, I don't know about you. I would probably pick the lake path. It seems the prettiest to me, but maybe we feel like going for a trail ride in the woods, but we're trying to see in particular what is the probability associated with the hilly path. Okay. So in part A, it says out of the older group, what is the probability that the cyclist prefers a hilly path? And so another way of thinking about that is we're looking for the probability that the cyclists prefer a hilly path given that they're already in the old category. I don't want to say given that they're already old, but given that they're categorized as old, okay? And so if we think about this, we have formulas, when we were given the probabilities, but when we're given a contingency table, we really just want to pick numbers from the table to divide. And so in particular, I want to look at the older group, right? And so in the older group, I see that 26 like the lake path, 52 like the hilly path, 12 like the wooded path, and there were 90 older folks in general. Okay, so I want to know hilly path is 52 out of the total of 90. So 52 over 90. And we take this, we put it into a calculator, and we get 0.5778. Okay, and so that's how we read that table. But let's practice with part B. So part B said, are the events being older and preferring the hilly path independent events? And so in other words, what we want to find is probability of hilly path and probability of being older, are those independent or not? And just as a reminder, okay, we have sort of three things that we can check for when we're looking for independence in our events. So the first thing we can look for is that the hilly given the older will equal the probability of hilly, okay? We could also say the probability of being older, given that you've chosen a hilly route, is going to be the same as the probability of getting older, right? Or the third one, so 1, 2, the third one is looking at the probability of older and hilly, an older person and a hilly route should be the same as the probability of getting an older person times the probability of a hilly route. And so when we did our other examples, one thing that we did was we looked at the data we had to see which of the three forms would be the most useful for us, okay? Now, I don't see any information about older and hilly, so I'm not going to use this last one. But what I do notice is that I found the probability of the cyclist preferring a hilly path in the older group, which is this. And I bet that I can find what my probability of people choosing a hilly route is, okay? And so let's go back to our table and find of the hilly path, all right? We have folks who are looking at the hilly path, how many of them were there? And so we've got the hilly path has a total of 90, and it's 90 out of a total of 200. Okay, so we're reading sort of down the column now and comparing it to that total. And so we have, let's see, probability of the hilly out of the older group is 0.5778. And we want to know, does that equal the probability of just choosing a hillier path? And if we do that, that is the 90 over the 200 or 0.45. Okay. And I think we can see from here that this probability of preferring a hilly path when we're older and the probability of just choosing a hilly path, those are not the same value. And so what that means is that there is some sort of dependency happening between your age group and which path you choose. Okay, so let me get that all on one screen for you, but I hope that was helpful. Let me know if you have any questions, and I hope to hear from you soon.